Our Earth is called the blue planet, as more than 70% of the Earth's surface is water-covered and holds about 97% of all Earth's water. But even today, the unexplored oceans hold mysteries more compelling, environments more challenging, and life forms more bizarre than anything the known cosmic space has to offer. Our knowledge of the ocean is limited, especially considering the fact that more people have gone into space on various missions, while only 3 people have descended to the deepest part of the ocean, the Mariana Trench in the Pacific Ocean. Taking up this challenge of exploring and sustainably harvesting the vast resources of oceans, the Department of Ocean Development, now the Ministry of Earth Sciences, Government of India, established National Institute of Ocean Technology (NIOT) in November 1993 at Chennai, with a mandate to design, develop, demonstrate and utilize ocean technologies for the benefit of the country. NIOT's Ocean Electronics Group was formed with a main objective and focus on the development and indigenization of new ocean observation technologies, development of marine instruments and communication systems. The Ocean Electronics Group has successfully developed and transferred technology of AUPD floats for 2,000-meter depth. It has developed data encryption for autonomous underwater profiling drifter AUPD. The group has indigenously developed the Deep Sea AUPD, intended for deep sea profiling up to 5,000-meter depth. The float operates by actively changing the buoyancy in order to ascend or descend through the ocean. This underwater platform carries different sensors on it and profiles the seawater parameters at predetermined depth. The prototype system completed for 500-meter profiling is pre-programmed for a typical profiling cycle with a microcontroller-based embedded electronics. The system periodically ascends to the sea surface, reports to satellites Argos and INSAT, and descends back to its parking depth for the next cycle. The Ocean Electronics Group has indigenously developed drifting buoys Pradyu with INSAT communications. The drifter buoy collects the meteorological and oceanographic information like sea surface temperature, atmospheric pressure, sea surface salinity, GPS position data, and transmits them using INSAT-based communication system. Drifter buoy consists of 2 sections. The surface float houses data acquisition electronics, battery pack and sensors. The second is the drogue, which acts as a sea anchor connected to surface float by a tether wire. The ocean current measurement is derived from the GPS position data. NIOT has established open sea fish cages at various places along Indian coast. The interconnected grid of cages will be floating on the sea surface. During bad weather condition, the cage is required to be submerged to reduce damages due to high waves. These cages are generally moored in sea at 10 to 15 meter water depth. The automatic submergence is achieved using a remote command communication. Prototype testing of a small cage was performed at sea. Currently, the design of 9-meter diameter with automatic submergence using pumping in and out of the pipe has been completed. Relationship between the sea surface temperature SST and weather patterns are getting more significant in recent years. SST has direct impact on the mixed layers in shallow waters. The Institute has developed a profiler for aiding in the collection of real-time in-situ oceanographic data using a tow fish operated from an ocean-moving vessel, which is highly economical and will be one of its kind in India. At present, the tow fish payload is conductivity, temperature and depth CTD sensor, which can be enhanced based on the requirement. The CTD measurements from shallow water regions at very close intervals provide vital data for further course of research and improve weather models. The group is also working on the wireless-based expendable CTD profiler WXCTD to measure seawater temperature from surface to depth of 500 meters using remote communications. Gliders are unmanned autonomous underwater vehicles with variable buoyancy. A pre-programmed value of buoyancy and attitudes aids the glider to efficiently voyage horizontally and slide along vertically. The Institute tested glider Bharati at the Central Bay of Bengal. The glider is equipped with conductivity temperature profiler and GPS. It was programmed with series of missions to dive to a maximum of 950 meter depth and climb back to surface. The surface positions from GPS were recorded before and after glide. The equipment is programmed to sample at every meter of descending. Government of Gujarat through Kalpasar Prabhag is undertaking a vast freshwater reservoir development by reclaiming the Arabian Sea in Gulf of Kambat. NIOT is playing a major role in carrying out seabed investigations, construction stages, post-dam effects and design criterion. Ocean Electronics Group along with Coastal Engineering Group of NIOT has established the Calob's Met Ocean Observatory that consists of 18 observation stations in remote locations across 450 kilometers on the coast of Gulf of Kambat. The group has carried many technological innovations and transferred technologies to Indian industries for commercialization. An MOU is made with National Research Development Corporation (NRDC) New Delhi for commercialization of indigenized technologies.